Question 9 is from 2020 paper 1. It was question 13. Here we have a recurrence relation. It has a constant k, and we're told two pieces of information about it. We are told that it has a period of order 3. Now, that's quite important for the next step. What that means is it repeats every 3 terms. So the first term would be exactly the same as the 4th term. So an order 3 would be a sequence where it would go A1, A2, A3, and then they would repeat in groups of 3. So A1 and A4 must be the same. Similarly, A2 must equal A5, A3 must equal A6, and so on and so on. Okay, and you can see the difference between the subscripts is obviously 3, which is where the order 3 comes in. Okay, the second piece of information is that the first term is equal to 2, and we have to show this quadratic here. So let's have a look at the information. The first term is 2, so if I start with that, A1 is equal to 2, and this is obviously part A. Then using the recurrence relation, A2 must be k multiplied by A1 plus 2, and then you divide all that by A1. I'm just following the instructions, that's all. Subbing in the A1, then we're going to get k multiplied by 2 plus 2 all over 2, which is equal to 4k over 2, which is equal to 2k. So we've now expressed our second term, it's in terms of k. Okay, so that's good. So we've got the first 2 terms. Now we also need to find the next term. So let's find A3, see what goes on there, because remember the first 3 terms are different. Now A3 is going to equal k multiplied by, this time A2, because you take the previous term, and then we're going to add 2 to it, and then we're going to divide by the A2 term. Okay, now if we do that, we've got k multiplied by 2k plus 2 divided by the 2k that we found earlier. So this is going to give us 2k squared plus 2k divided by 2k. And if we simplify that term by term, this was going to give us k plus 1. We're assuming, obviously, k is non-zero. Okay, wouldn't make for a very interesting sequence if it was. So we've now got A3. So we're doing pretty well. We've got A1, A2, and A3. Now, A4, we know is going to be identical to, I shouldn't say that, it's equal to A1. So we just need to find one more, and then we can set up an equation. So A4 is whatever we get when we sub in A3. So that's going to be k multiplied by A3 plus 2 divided by A3, which is going to equal k multiplied by k plus 1 plus 2 divided by k plus 1, which is going to be k multiplied by k plus 3 divided by k plus 1. I can't simplify that. I'm just kind of stuck with it. So we've generated the first 4 terms, okay, including the one that we're given. So our terms are as follows. So we have 2, we then have 2k, we then have k plus 1, and we now have k and then k plus 3 divided by k plus 1. And because this is periodic, as I've already said, the first term and the 4th term here are equal. So that means we can set up an equation. So I'm just going to erase what I've done here so I've got a bit more space. And If we put those equal to each other, let's see what happens. So we now have A1, which is 2, must be equal to k multiplied by k plus 3 all over k plus 1. So the first thing to do is to multiply both sides by k plus 1. So we're going to have 2 lots of k plus 1. And I'm going to expand the bracket in the numerator. That's going to equal k squared plus 3k. This is going to be 2k plus 2 is equal to k squared plus 3k. Let's collect all the like terms. So I'm going to have 0 is equal to k squared. I've got to subtract 2k, so it's going to be plus k, and subtract 2. Okay, so that checks out. Now for part B, it asks us to explain why k is not allowed to equal 1. Well, why has it said 1 specifically? Well, we can factorize this quadratic. We can get k plus 2, k subtract 1 is equal to 0. Okay, that's if we factorize it, which would imply that k could equal -2 or k could equal 1. But we're told that k equals 1 is not allowed. Now, why is that? Well, if we plug in k equals 1, so plugging k equals 1 into the sequence would generate the following terms. So obviously the first term would be 2. Then if we plug k into the second term, that's also going to be 2. And then k equals 1 into the third term, which was k plus 1, that's going to be 2. And then in the fourth term, that's obviously going to be the same as the first term. So it's going to just carry on like this. Okay, so this sequence would not be periodic order 3. That's the problem. It's the same term over and over again. So it would break that condition. Okay, because it generates the same term over and over again. Now for the last part, C, we have to find the sum of the first 80 terms of this sequence. Okay, now we've just established that k cannot equal 1. So this forces us to use k as -2. That's the only possible option. So if k is -2, let's generate the first few terms of the sequence. So k equals -2. What do we get? Well, obviously the first term is 2. That's fixed. Then we have 2 times -2, which is -4. Okay, and then we have k plus 1, which is going to be -1. Now, if everything's worked out correctly, if I sub -2 into the fourth term here, that would give us -2 multiplied by 1, which is -2, all divided by -2 plus 1, which is -1. So that's -2 over -1, which is 2. So yes, we do get 2. And then because that's the same as the first term, this cycle will repeat. Okay. So imagine there are 80 terms in this sequence. So this goes along for 80 terms. And we've got to add them up. Remember, that's what the sigma notation means, to add up, to sum. Well, we've got groups of 3. So how many groups of 3 are there in 80? That's the first thing. Let's just do that on our calculator. So we have 80 divided by 3, which gives us 80 over 3, obviously, but that would be 26.6, which is 26 remainder 2. Okay, so we'll just put that calculation down. So 80 divided by 3 is going to give us 26 remainder 2, like what you did in primary school with the remainder. So that means that the sum of the first 80 terms is going to be 26 of the first grouping of 3. So we have to add up the first grouping of 3, and there's going to be 26 of those. So that's going to be 2 subtract 4 subtract 1. If you add up the first 3 terms, there's 26 of those. But because we have a remainder 2, we're going to have to add on the first two terms again because it repeats in cycles of 3. So that's going to be +2 and then subtract 4. Okay. Now this is going to be 26 multiplied by 2 subtract 4, which is -2, subtract 1, which is -3. And then we're going to have to subtract 2 from that. Now that's going to give you -80. Okay, for your sum, don't worry that it's negative because we've got negative numbers in the sequence.